I'm going to teach very basics of periodic inventory system using a simplified example. Suppose demand for our product has an average of 10 units per day, and suppose standard deviation is 5. We review our inventory every 30 days. Lead time is 12 days. Ownership of product is transferred to us as soon as we place an order. We will have pipeline inventory from the minute that we place an order, and it takes 12 days to receive that order. Now we want to know how much should we order. I explain everything step by step, and I avoid to make the problem complicated. So I only touch very basic concepts. So I am at this point. It is 12 days to the end of the period, or 12 days to the beginning of the next period. And when I place an order, I will receive it here. And then up to this point, when I receive the next order, I will have no control. I cannot add to my inventory. Lead time is 12 days. Review period, 30 days. Therefore, from the time that I place an order, I do not have control for 12 plus 30 days, which is equal to 42 days. So as long as safety inventory is concerned, safety, from the time that I place an order until the time that I get next to the next order is 42 days. And I should protect myself against stock out demand during lead time, or lead time demand is square root of L plus T, that is the period that I do not have any control to add to my inventory, multiplied by standard deviation of the daily demand. And that is equal to square root of 12 plus 30 multiplied by 5, which is standard deviation of daily demand, and that is equal to 12 plus 30 square root multiplied by standard deviation of daily demand, which comes out 32.4. And my service level is 97.72. The reason that I have chosen this number, because it is just 2 standard deviation to the right, z is equal to 2. So if I multiply this one by 2, and if I round it, then my safety stock would be 65. Safety is equal to 65. We are done with one piece, but we need more pieces of information. When I place an order here, then for this much time, I cannot do anything else. How long it is? It is 12 plus 30. L plus T equal to 12 plus 30, which is 42. And the daily demand over that period is 10. Therefore, I need 10 times 42 equal to 420. So that was the demand during lead time plus the demand during the period. Therefore, when I am at this point, I should have 65 plus 12 times 10, which is 120, plus 30 times 10, which is 300, and that is 420, and that is 65. Okay, now at this point, when I need to place an order, I know that I need 65 plus 420, but I do have this much on hand at this point. I have this much inventory, therefore I place an order for the rest. Things like this may happen. But the interesting point is my inventory level, my maximum inventory level will never reach this level. Because when I place an order and I assume that I need this much, when I receive the order, I have already consumed that part. So this value of 65, which was safety stock, plus 12 times 10, which was average demand during lead time, plus 30 times 10, I will never reach this level. They call it order up to level. I will never have order up to level. At this point, what I order is less than demand during 30 days. At this point, what I order is less than demand during 30 days. At this point, what I order is less than demand during 30 days. But here, it is more than demand during 30 days, and here, it is more than demand during 30 days. Sometimes, it is less than demand during 30 days. Sometimes it is more than demand during 30 days. So on average, it is demand during 30 days. So if on average I order demand during 30 days, my cycle inventory is T times R divided by 2. We found safety inventory. I safety is equal to 65 and I cycle is equal to 30 times 10 divided by 2, and that is 150. I would like you to fill this issue. Let me remove variability. Let me change this standard deviation to a very small number. Let's see what will happen if everything is on average. If we do not have variability, when we reach this point, we have the demand during this 12 days, and because we have no variability, so we do not need safety stock. How much do we order? We already have for 12 days, therefore what we order is what we need for 30 days. And then when we receive that order, we have nothing available, and therefore our inventory goes up to the demand of 30 days. The same is here. When it is 12 days to the next period, inventory on hand is equal to the demand during lead time. Therefore, I only order what is needed during the period, which is 30 days. Therefore, each time what I order is exactly what is needed during 30 days, during the review period. It is not what is needed during 42 days. It is not what is needed for L plus T, because on average, I always have on hand what is required for L days or L periods, and I only place order for duration of each period, which in this case is 30 days. More than what is needed during lead time, more than what is needed during lead time, little bit more than what is needed during lead time, less than what is needed during lead time, less than what is needed during lead time. less than what is needed during the time, less than what is needed during the time, less than what is needed during the time, more than what is needed during the time, slightly more than what is needed more than what is needed during the time, more than what is needed during the time, less than what is needed during the time, less than what is needed during the time. So on average, we will have what is needed during the time, and then we have that one, we have the safety stock. All we need is what is needed during the review period, which is 30 days. The situation becomes very clear if we remove variability. Always when we want to order, we have what is needed during lead time, so we only order what is needed during the period. I safety equal to square root of L plus T times the daily demand or weekly demand, depending on what unit is this, standard deviation, multiplied by Z of service level. In this example, Z of service level was 2, sigma R was 5, and 12 plus 30. That is I safety. What we order is equal to T times R, that is 30 times 10. I cycle is equal to Q divided by 2, which is 300 divided by 2. What about I pipeline? That is from the time that the ownership is transferred to us. So at least we will have financial holding costs for that for a period of 12 days. How could I compute I pipeline? There are two ways to compute I pipeline. First, by using the Lidl's law. Throughput times flow time is equal to inventory. Throughput is 10 per day. Flow time is 12 days. Therefore, 10 times 12 is 120. That is our pipeline inventory. I pipeline. I safety equal to 65. I cycle 150. I pipeline equal to 120. Suppose holding cost when it is in storage is $2 per unit, and when it is on the way, which does not include rent and the storage cost, it is equal to $1. This is in storage, so that is 65 plus 150 times 2. That is carrying cost in storage. Pipeline is 120 times 1, that is pipeline cost. Pipeline cost usually only is financial cost, but not labor, not rent. Storage cost include all of them. A second way to compute the pipeline inventory cost is we have 3,600 units of product, and when they are in pipeline, cost is $1 per unit per year. If all of these 3,600 were in pipeline throughout the year, cost per unit was $1. But they are only there for 12 days out of 360 days, because we assumed 12 months and then each month is 30 days, 360, and 10 units per day, that was 3,600. Because we are there 12 days over 360 days, therefore the cost is not $1, because they are not there for a whole year. So this is multiplied by 1, and then that is multiplied by 3,600. And that is again exactly the Little's law, because if I take this 3,600 over there, that would be 3,600 divided by 360, which is equal to 10, which is my throughput per day, and this 12 days is my T. So while this is in a different language, it is also the Little's law. Thank you very much for attending this session.